Let's take a look at all the different things that we have learned so far this term. First of all, we learned about igneous rocks. Now these are rocks that come from the magma that's deep in the earth, the molten rock, and if they form underneath the earth, slowly cooling, they have large interlocking crystals like this, and if they come out of the crust of the earth and extrude out and cool really quickly, they have small crystals like this that are so small that they can't interlock, and some of them don't have any crystals at all, like obsidian. And these igneous rocks vary in many different degrees depending on what they are made out of, what types of minerals. But one thing happens with all of them: nothing lasts forever, because we have weathering. Weathering causes all types of rocks to break down. This one here is being eaten away by lichen and also being split by water that's been frozen in the cracks in the rock and split the rock apart. Here we have more lichen that's eating this rock away, quite literally eating it away. And if you have things made out of rock, they don't last forever. As you can see here, this is a result of chemical weathering because of acid rain. Now when you break rock down, we learnt then that it turns into sediments of different sizes, either coarse and grainy or very tiny and fine. And those sediments can then be moved or eroded by wind and by water. And once you've eroded those sediments and moved them away, they actually have to land somewhere. We call this deposition. And here's a wonderful picture of deposition from space. These are sediments that have been washed out to sea from the land, most probably some poor farmer's topsoil. We had this recently when we had the floods a couple of years ago, where tons and tons of topsoil were washed off farms and ended up in Moreton Bay and killed all of the seagrass that was there. Once you have those sediments being deposited, wherever they get deposited, they then get compacted down as they layer upon each other and eventually cement together to form sedimentary rocks. Now, these are different types of sedimentary rocks. Again, the type of rock depends on the sediment that it's actually made from in the first place. And sedimentary rocks can have sediments of very coarse sediments, like conglomerate, or very fine sediments like this mudstone here. But again, nothing lasts forever. These sedimentary rocks again are exposed to weathering and can actually be weathered away, the same as we saw the igneous rocks. Or if they are heated up or exposed to huge amounts of pressure in the crust, we find that these sedimentary rocks and the igneous rocks that we first learnt about can both be turned into a new third type of rock when heated or pressured, or both. And that's where we ended up with the final rock to learn about, which was metamorphic rocks. And this is where sedimentary or igneous rocks, or even metamorphic rocks, are cooked, heated, pressured, so that the minerals within them rearrange themselves and reform into foliated layers like this, become extremely hard and strong, and form various types of metamorphic rock. And the type of metamorphic rock depends not only on what they originally were, the parent rock, but also how long they've been under heat and pressure, because the longer you put them under heat and pressure, the more metamorphosized they become. So there's several different levels of metamorphic rock, and each one has their own name. So in full circle, we call this the rock cycle. This is where any one type of rock does not last forever, but is in a continual cycle of either being formed or changed or eroded down or melted to continually move around in this cyclic manner. Everything at the beginning starts as magma, but that magma can then solidify and crystallize into igneous rock. Igneous rock, if exposed to too much heat and pressure, will metamorphosize and become metamorphic rock. Or, if it's exposed to weathering, it will break down and form sediments, and those sediments will then turn into sedimentary rock. Sedimentary rock, if exposed to heat and pressure, can turn into metamorphic rock as well. Now, metamorphic rock, if it's exposed to enough weathering, will actually erode and be weathered down and turn into sediments, but it takes a lot longer than the other two. And all three types of rocks can be melted back into magma when exposed to enough heat. And once they're back to magma, the whole process starts all over again. So that is, in a nutshell, what we call the rock cycle. And it's something that is continually reshaping the land around us. It's the reason why the volcanoes of old no longer look the way they did, and in fact are a small percent of the size of what they originally were. What we see in the Glasshouse Mountains is simply the plugs of the original volcanoes. We do not see what size they originally were. So the rock cycle continually changes our environment, and it's powered by an underlying convection current underneath the crust that's continually moving and pushing our crust around, squishing rocks together to make them metamorphic, pulling crusts apart to release magma up through the crust to make volcanoes, pushing large amounts of crust down below others, like this, to force them back into the magma below and start the whole cycle again. So the rock cycle continually changes the environment around us and is continually reshaping the world as we know it. And you're going to be using this knowledge to help you understand not only what you see today, but how you can figure out what happened to make it look that way many, many years ago.